Welcome to Casting Class, the engineer's podcast for all things metal casting. Casting Class is brought to you by Batesville Products, the manufacturing experts who've been casting, machining, and polishing custom aluminum components for over 75 years. Today we have Rachel Weber here to talk about her experience helping engineers convert fabrications into aluminum castings. Kind of kicking it off here, we'll start out with a scenario. So picture this.
Okay.
Rachel, you're at a trade show, an engineer comes up to you, he hands you a part, hands you this hodgepodge of 12 differently machined pieces that are then welded together, and he asks if there's any way to manufacture this better. So what would you do in that scenario?
I guess there's a couple different things you could think about. One is you look at the part itself, different wall thicknesses, how thin are the walls. Is it possible that you would need to have moving aspects of it? Does it need to be multiple separate parts? Is it assembled for a specific reason? That way you're like, you could either cast it in 3 different parts, one solid piece. Another factor is to consider how many are they looking to make. When you're looking at this hodgepodge, is it worth it to cast it? Because once you start getting into the casting side, permanent mold, you have to consider the tooling upfront cost. Do they have different materials welded together? Are they okay using one material to be casted all together? A lot of factors to ask.
That's a good point. You brought up that even if it's 12 pieces, you could maybe narrow it down to like 3 pieces. So even casting like some of the parts together could save a little bit of time on that.
Definitely.
So why we have a lot of customers that come to us with fabrications like that, and then they'll ask us to convert it into a casting. So what would you say are the benefits that they're getting by converting their fabrications into a casting?
From a time perspective, you're going to save a lot on labor because you're not going to be having to make individual parts and then weld them together. You're casting into one solid piece. In terms of strength, that's something you could consider. You don't have a weak joint like you would in a welding. And you're also not having to manage multiple drawings, I guess, if you would consider that from an engineering perspective or a purchasing perspective. You have less components you have to worry about purchasing or buying or making sure all getting produced at the same time.
That's true. If you're getting all those different pieces too, you might want to inspect all of them, and then that's an extra step to add in.
Yes.
With the labor that you brought up, you're adding in a lot of machine time, and welding is really expensive. That's a lot of labor. I think there was one customer that we had come through, they saved like 40% and paid off their tooling in record time because of that labor cost being so high.
Yes, and depending upon the type of facility you're looking at for welding, some of them have robotic capabilities, but in general, welding is a skill set that it's kind of like any type of manufacturing is a dying art, where it's becoming either you have the skill set or you have the robotics to do it. It's a little bit harder to find nowadays.
You're going to have such a short amount of machine time compared to if you're just cutting it from billet. I mean, it all depends on how complex the part is, how big it is.
Yep.
But you're starting with, instead of going from a block, you're starting with a near net shape of the product.
Correct.
And just adding in those tighter tolerances or the little features that you need to hit.
Yeah, because sometimes there are certain features that are considered critical, and then there's other features where you're like, I just need it to be that close to the shape as possible, and you're reducing that amount of time getting it there when you're doing a casting.
Our website's full of different case studies where we turn these weldments into castings. There's one with a medical cart base from a steel weldment to an aluminum casting. There's others in the food and beverage industry, medical, all kinds of different applications. One that I wanted to talk about, that long medical one that has like 4 different walls sticking out of it.
Yeah, so that one was before my time, but I did hear about it. It was used for a blood testing equipment.
Yeah, that one it looks very complex, and it has 4 different walls sticking out. I can't even tell which side is the front side.
The best way to describe it is like a tree. Just everything branches off from it. And it was all fabricated pieces put together. and we were able to cast it into one part. When you look at it, it looks like a pretty complex part, but you just add a couple different pools in your tool and you can get some pretty cool different shapes when it comes to casting. So you can get pretty complex when it comes to casting a part. It's just a little bit more complex the part, maybe a little more expensive the tool, but you have to see how the cost outweighs or what the return on investment is compared to welding all those pieces together.
Especially if you're making a lot of them, because
Yes.
if you're machining thousands of them, it's definitely going to be a better return on investment to cast it instead.
Yeah.
But it's still very precise because it gets a little bit of secondary machining to hit all of those tolerances.
Yes. Yeah.
And then there's also that medical part. It's like a cylinder, but it's hollow inside and it has windows all around the sides. So it's actually very thin walls.
Yep.
And there's not really much metal going on. That's a lot of cutting.
Yeah, well, you look at it and you're almost like, is this an extruded part that you machined? Like, or did you extrude it? And then it looks like a fabricated part with how well finished it is. It's pretty impressive. Extremely thin walls. We cast it and then the whole surface is machined, but you're going to save a lot of time machining it from a casting versus a billet because just of the shape of it itself. It's going to take a lot of material to take it up, get it all to where you need it to be.
Lots of material.
Yeah.
So to help out our design engineers listening, when does it make sense to manufacture your part by welding, and when does it make sense to switch to casting? Just like a quick guide checklist for them to look at.
I would say there's a couple factors. One is quantity. Once you start getting, I would say 500 pieces or more, you're going to want to start looking at a more efficient way to produce the part, because the higher the quantity and steps that have to touch the part, the higher the piece price is going to be, especially when you're getting into welding pieces together. So, I mean, at our process, we typically say 500 is kind of the buy-in rate for permanent mold when you start to see return on your investment for the tooling.
That's when it starts to make sense.
Yeah. And even before that, you can look at sand casting as an option too if you're not ready to take the dive into a permanent mold tool.
Yeah, sand casting, it's a cheaper tool, so it's a lot easier to get into even for prototyping one of those parts. You just won't have the same finish.
Same finish, not quite the same density as a permanent mold. You're going to have a little more inclusions, potentially sand inclusions happening, not as nice of a surface finish, and the near net shape is not as tight of a tolerance. You have to add a little bit more stock when it comes to sand casting.
And then also, I think it makes sense to really evaluate your size and your complexity. So if you're making, little keychains that are super simple, leaving that on the machine would make sense.
Yeah.
But if you have these parts with multiple walls coming out and they're not very symmetrical, it's all a lot of geometry internally and externally, then it would make sense to switch.
Yeah. It's not going to be efficient to machine a part once it starts getting too big from billet.
Yeah, I think a lot of our castings, they're anywhere from 1 pound to 100 pounds.
Yeah.
So a really big size range in there.
Oh, yeah.
So are there any things to look for in a design that right away let you know, oh, this is a great casting or this is a great fabrication? Or the other way around, if you're looking at a design, are there any red flags that kind of show that they are limiting themselves to just one manufacturing method?
I would say from machining to casting, if it's a pretty simple rectangle with maybe a few machined holes, you're like, stick with machining it. There's no point in casting it. Same with if it's a cube and you've got a few screw holes that you have to put in there. Once you start getting more complex shapes going on with it, that's when you want to start looking at casting it. And then also wall thickness. If you're looking at anything below 1/4 inch wall thickness, you're going to look at probably either die casting or even a different process, because when you start getting into casting, you need a specific wall thickness to start filling in.
Yeah, so for a design to be able to be manufactured with permanent mold casting, you need that 1/4-inch wall
Yeah,
thickness
18
pretty much.
thousandths wall
Mhm.
thickness so that you can get a solid fill. And also, another thing to consider is if there's multiple different wall thicknesses of you're designing it, think about how would you feed that metal into those areas. Are you basically designing it where if you have to flow through a really tight corner to fill into the other side, you're going to start freezing off that other area. So start considering if you're going to try to cast this, you have to figure out a way to design it so that it fills in properly.
Mhm. Castings have to have that transition between the thin and the thick. You can't do abrupt changes
Yeah.
with your thin and thick walls. And then draft is another thing to consider that you don't really need in machining, but you definitely need that in casting.
Yes, so if you need a straight 0-degree draft, that's gonna have to be machined, or you're gonna have to cast and machine down to the 0-degree draft. So that's another thing to consider, and also flatness. How much flatness is required, and how big of a surface is it too?
You can do the secondary machining operations to kind of hit those after casting again if you have that near net shape, but it's factoring in all of the different factors that go into it of your complexity, the size, how many you're manufacturing.
Yeah.
So I think we covered just about anything and everything.
Okay.
So do you have any last pieces of advice for listeners who might be trying to learn more about what manufacturing options are out there and when to use what method?
I would just say that you can cast anything, but doesn't necessarily mean it's the most efficient route to do it.
I would even switch that and say you can machine anything, but it might not be the most efficient.
Yeah.
Yep.
Just talk with your suppliers to figure out if they believe that process is good for their manufacturing facility, and if they have any recommendations on how they would suggest casting it or even manufacturing it, because they're in the process day in, day out, so they know what they're talking about.
Mm-hmm. Thanks for listening to Casting Class, the Engineers podcast for all things metal casting. For more episodes, videos, and guides, check out BatesvilleProducts.com. See you next month.